Hi everyone, my name is Kyle Milani. I'm Director of Product Management. I am the product manager behind the trusted aspect of MarkLogic, so all features related to high availability, replication. I'm also responsible for things like security, including encryption and the management aspects of the product. Today I'll be talking about elastic resilient cloud aspects of MarkLogic, and Wayne will be helping me. Wayne?
My name is Wayne Fike. Principal engineer in the engineering organization. I've been with the company 8.5 years, and I've built out most of the HA and DR technologies, a lot of the security, some of the indexing, things like that.
So you guys can see from the presentation, he will answer all the tough questions. I'll keep with the easy questions. So today in the agenda, we'll talk about a little bit about the traditional way of scaling MarkLogic. I'll briefly talk about how we can do it. It's fairly easy, how we can do it. And I will talk about alternatives, and at the end, some caveats. But before I do that, I want just to have a show of hands. Who's already managing MarkLogic in production here? Okay, you have about half of the audience. So you may already be facing the question about how to scale, or may already had to scale in the past. But for those that are not, you learned from the presentation from Gary Bloom that MarkLogic is really good at doing a few things, and among those, getting data in and getting data out. So the more data that you get in or get out, the higher the stress on the cluster, and therefore you need to scale. But great news, it's very easy to scale with MarkLogic. Have my example here, a 3-node cluster. You just add a node, couple that node to the cluster, add some forests, and then the rebalancer will kick in and start moving data to the new forests. Any ingestion that starts happening, those new forests will already be handling part of that ingestion. The great part, it's non-disruptive. You add that node, the application will continue to run. The rebalance is a background process, so the performance will always be really good. You can fully automate. We have APIs to automate the process of adding that node. So great solution. That's what most customers will do, and those that already are managing probably already went through this process of adding nodes. Works really well on the cloud. Joe Pascal mentioned, and you cannot present it with other clouds, so it works really well in the cloud, so that's what customers do in the cloud. But the question that I want to answer today is just adding a node the best solution for all use cases? And to answer this question, I have a few things to have in mind. The first is about users, what they need in terms of contemporaneous information. And by contemporaneous, I mean you just inserted one document to the database. Do all users need to see that document immediately in all queries that they are doing? If some users can tolerate being a few seconds behind, we'll talk about alternatives and how you could scale. The second aspect is what you are trying to solve. Are you trying to solve a problem about ingestion, about query, or about analytics? And that's why I asked about users in the audience if you're already managing. It's best to observe this. It's best to already have the cluster running for you to understand what is the problem, to figure out if you're having problems with I/O, and therefore it's an ingestion problem, and so on. It's best to observe that. The other aspect, probably not all data has the same importance. Maybe some older data, you don't have to have very fast query response for that old data. So we'll talk about what you could use in MarkLogic to accelerate your ingestion performance of new data. And finally, maybe some users are not in the same location, and you may think about how to use replication to improve the scalability of your MarkLogic deployment. So for each different aspect here, let's say you're trying to solve a read-intensive need, we'll talk about e-nodes. If some users tolerate a lagged read, therefore they tolerate being a few seconds behind, we'll talk about how to use replica clusters. If you're trying to solve a write intensive, we'll talk about fast data director and tiered storage. Analytics, Wayne will cover how to use e-nodes and replication. distributed users replication, and finally archival tiered storage. Okay, so let me start with read intensive. And before I talk about the solutions, I want to classify what I mean about read intensive. It's an application that has a small amount of data at the top, but large amount of concurrent requests. So many queries, not lots of updates or inserts, right? Lots of queries. And there are two things that you can do. The first is more from the developer side. You should try as much as you can to use unfiltered queries. What is a filtered query? You do a search. Let's say you're searching for dogs and cats. MarkLogic will try to find all documents that have dogs and cats. But then if you're doing a filtered query, to avoid false positives, it will actually open the documents and see if the documents have dogs and cats. Let's say you're trying to find dogs and cats in the same, near one to another. We'll try to be sure that that document contains the information that you're looking for, so you don't have a false positive. That's the filtering part. And that's done by eNodes. So I'll talk about how to solve problems if you cannot tolerate false positives, what you should do. And the other alternative is just to add eNodes. Let me talk in more detail about eNodes. What is an eNode? MarkLogic has a single installation, it's a single process, but depends on how you configure MarkLogic, we will classify that as an eNode or a dnode. A dnode is a node that has forests. So if that node you configure to have forests, meaning data, that's where we store data, we'll tell that that node is a dnode. If that node has only app servers, we'll tell that's an eNode. Most commonly, probably most of the customers will have both forests and app servers, and that's a dnode. So my solution here to solve the problem of read intensive is to separate eNodes, because eNodes will do the filtering. So if you have lots of queries, eNodes will get the documents, expand into what we call the expanded tree cache, go through the document and ensure that you don't have false positives. Therefore, if that's your performance problem, you are struggling to keep up with the queries, by having separate eNodes, you can have more cache allocated to your expanded tree cache. And therefore, you'll be resolving queries faster. As well, the eNode will do the processing for your server-side code. So if you have a lot of server-side code, the eNode will help there. So that's a solution that will help you scale and read intensive. This solution is for contemporaneous, meaning that every user expects to see information that was just inserted into the database. But if some users tolerate what I'm calling here lagged, they tolerate seeing information a few seconds behind. We have two options here that I want to cover. First is read-only replicas. The second is what I'm calling transient architectures. Let me start with the first. Very simple. My scenario here is a very simple cluster. These are DE nodes, meaning that they are app servers and data nodes at the same time. So DE node. I have my 3-node cluster that I'm calling the master cluster, and I set up replication to my DR cluster. Our replication is asynchronous, so that means that those users in the remote cluster, they are slightly behind. The information is slightly behind. But you can use that cluster to respond to queries. Those users will see a few seconds behind the queries. But there are many, many applications that's okay. And when you do reads at the remote cluster, you are actually isolating that from the master cluster. They are not competing. They are not competing with the ingestion that is happening here. But you can see here that I also have reads in the master. This solution can serve both types of users. I can still have some users that want contemporaneous queries, and they will be hidden in the master, and other users that tolerate lagged results will be querying the replica. This is a set once scenario. You will just set it once. You will set the replication, and you will set your load balancers and your app servers, and that will work for a long time till you need to scale. And if you need to scale, you add nodes separately to the clusters. Okay? This is very common. Many customers are already using this. The other alternative, it's what I call transient clusters. Steve Bertoli presented yesterday a very similar scenario. This is, again, already used by one of our largest clusters. It's very similar to the previous scenario. I have my master cluster, but in this cluster, they are just ingesting data, and here they are getting feeds, news feeds. They are coming to the master cluster. So think about Associated Press, World Press, things that are news coming here. And what they do, they create a 3-node cluster. They set replication. And as more users start doing queries, they instantiate more clusters. This is running in Amazon, so they can do that pretty quickly. Let me just walk you through how it works and why it's very effective. So you have the master. You're running in Amazon. Vitaly just told you that you have to have EBS volumes. So you have EBS volumes here to hold your data. What you do a snapshot. You create that new cluster. You mount those snapshots to the cluster. And then you turn on replication. Since you just did a snapshot of the volumes, that new cluster is just a few, maybe a minute behind the master cluster. So replication will pick up very fast. And that cluster is within a region, be a few seconds behind in terms of what information it contains. They scale throughout the day. They are using Chef to automate this process. And they are using a scheduled scalability because they kind of understand the demand. They know that beginning of the day, tons of users will try to find news about MarkLogic. They want to know everything that is happening about MarkLogic. But at night, nobody is awake, 2 a.m., so they will shut down those nodes. So they do that throughout the day. They add nodes and they shut down. Great part, Amazon, pay as you go. So this is a very, very scalable solution. They serve tons of users. They serve really, really complex reverse queries here. And again, the same concept, those are isolated. So you can continue to ingest. Very scalable and very resilient. If I lose that cluster, not a big deal, right? And because those are clusters, if I lose even nodes, still working. Very scalable and resilient. Now that we're talking about read intensive, I want to talk a little bit about the other side, the write intensive. Again, I would start by qualifying what do I mean about write intensive. It's kind of the opposite. It's an application with lots of data, but small number of concurrent requests. Lots of data. There are 3 things that I want to talk about here. We talk about E nodes. Let's now talk about D nodes as a way to solve this. I'll talk about other 2 features of the product, fast data directory and tiered storage. The first is just isolating, right? More I/O for D nodes. And the second and the third, we're talking about using fast media, which I mean solid state drives. Let me start with the D nodes. Recap, a D node, it's doing the filtering. So what a D node is doing? The D node is handling ingestion. Ingestion works. Just a quick brief of how it works. We get the documents, we save to an in-memory stand. Once that stand is big enough, we save that to disk. But MarkLogic is a fully transactional, ACID-compliant database. At the same time, we are always writing to the journal. So the E node is handling that. It's creating the in-memory stands, writing to the journal. When that stand is big enough, flushes to disk. Then you have stands in the disk. When you have many small stands, we'll do a process that is called a merge. We'll merge small stands into bigger stands, and then to bigger stands. Typically to 64 gig stands, you can configure that, but it will try to get to a larger stand. that optimizes a lot this throughput and also queries. That's the process that the D node is doing. As you can see, very I/O intensive. So the idea here to separate your D nodes is to allocate more I/O capacity, and I/O also requires CPU to be processed as well, to the D node. So when you separate those, you have more capacity. Think about having storage. It's almost like having a storage node that is handling all that capacity. And you can also play with the caches. I mentioned that expanded tree cache for an E node. The D node, you want to bump up the compressed and the least cache. So you allocate more cache to a D node, you will perform better. So you are putting more memory and more resources dedicated to the ingestion part of the process. Okay, so that's one aspect. The other is a feature of the product, fast data directory. Let me explain what it is a fast data directory. You will specify for the forests the fast data directory and the data directory. There's also the large data, but in my example, I'm using these two, fast data and data directory. Remember I just said how it works, creates the in-memory stand and writes to the journal. When you specify the fast data directory, the in-memory stand, when it's flushed to disk, goes to that directory. The journals as well will go to that directory. If I put solid-state drives behind that, much faster. Flush into disk, run into journals. The merge process, the initial merge process, if I have small stands, will also happen in the solid-state drive. As it gets bigger and bigger, MarkLogic will automatically move the stands to the hard drive. This is set once and forget. You set it once, MarkLogic will ensure that you are not running out of space. It will monitor that, and it will start moving data to your hard drives. Yeah.
Is there any general guidelines on the ratio of the size of the SSD to HDD? How do you determine the ratio of the size?
That's a good question. I'll get into my third bullet here. We did tests. We're working with Intel, which is one of our sponsors here, and we are testing. I think this was a 10-to-1, and we were using PCIe cards. In a 10-to-1, we got up to 100% faster. So kind of 10%, you're already getting a lot of improvements in terms of performance. There is a paper. I have the link at the end. You can read a little bit about that. But generally, you don't need much, okay? And you get great improvement in terms of performance here. Again, as a feature of the product, new technologies making this even better. So something to consider here. The other is tiered storage. Tiered storage, it's similar in concept. What I want to do, I want to have my ingestion going to fast media. But tiered storage also allows you to move data according to a policy. The previous solution, you just set it, and MarkLogic will figure out how to move things. Tiered storage allows you to set up a policy. I have tier 1 and tier 2. My example, I have 3 nodes in tier 1, 3 in tier 2. All those nodes in tier 1 are backed by SSDs. One important aspect when you ingest, you have to specify where you are ingesting. We handle this by using a concept of super database and sub databases. So ingestion goes to the sub database. So you ingest the sub database. That sub database is backed by 3 nodes. So all ingestion is going to those 3 nodes. It's completely segmented. Those 3 nodes will handle that ingestion. I can query at the super database level. The query will go across all sub databases. In my example, will go across all 6 nodes. Of course, the query in this example will be bound by the slowest tier, in my case, tier 2. Okay? Let me describe one policy here. I want to have every document that has an element, say creation date, that is older than December 31st, 2015. That will tell it's tier 2. So when you set that policy, all documents will start to move to tier 2. And you can set new policies. Let's say that every 30 days you create a new partition as part of tier 2. The rebalancer will start to move data. So tiered storage requires you to set up policies and tell what goes to tier 2. And you ingest in tier 1. This is the feature as is today. And as you notice, well, there is some configuration here. We're actually simplifying a lot in MarkLogic 9. This is already available in early access too, so you can already try it. So 3 main things that we're doing here. First, I exemplified a policy that I specified a date. I said December 31st. What you can do now is set up a query, anything that is valid as a query in MarkLogic. So you may think about dates, you may think about information inside documents. The traditional use case that we saw is documents for a foreign exchange have to be tiered in 1 day, documents for wealth management in 30 days, patient records in 30 days. Depending on the type of document, you can decide what goes. Any query will be valid. We thought about customers creating loops. So this will be an ordered list. The first document that matches, the first query that matches that document, where it goes. Even if you make mistakes, we'll not keep documents going across loops. And we will also allow you to specify age. I described December 31st, but what you will be able to do is tell I want documents older than 30 days, or between 30 days and 12 months. That goes to tier 2. So specify any query and age, and it will keep moving. But the best part is the last one. You don't have to use really super databases anymore if you don't want to. We will figure out how to handle queries, where to hit those queries. As Joe described in the keynote, we'll be smart enough. If you're asking for documents that are 20 days old, that's your query, that's your parameter. Why touch tier 2? We will not. We'll just go and touch tier 1. Yes?
Any benefits, advantages to still use a
Super database will give you specific control about where to ingest. Yeah, there are scenarios that you should still think about doing. It allows better control. But I'd say most users will probably not use it. Do you have something to add?
I have an example coming up.
Yeah. So again, for the early access too, great improvements here to simplify, make it very easy to use. Very powerful feature. So now, Wayne will talk about the other scenarios.
There it is. So if you think about what Kyle's been talking about so far, a lot of it is sort of your operational system, right? That everyday CRUD operations, create, read, update, delete. It's those quick transactions that you run your business on. But is that the right direction? Hmm? There we go. I didn't expect to go that way. Oh, I see. Hold it that way. Okay. It's all in perspective. So when you think beyond those sort of CRUD operations, right? Those fast-running small transactions that you're doing to keep your business going, there are a lot of other transactions, things you want to do around analytics and ad hoc queries. So we'll go through some examples. Content transformation. Now, you've modeled a lot of information in your database. You're representing many individual things. And sometimes you want to take those individual things and represent them in some new way, right? You're handing something off to a regulatory body or some other part of your organization wants a view of your data, and you're giving them a subset of what you know or something, right? So it's computationally expensive, it's expensive because you're laying hands on many, many things. Reporting's another example, right? It's kind of like content. Content was sort of a one-to-one transformation. Reporting is a many-to-one because you're boiling things up into high-level summaries and things like that. But again, you're laying hands on lots of different things. You're trying to generate lots of reports. It can be consuming of memory, disk, CPU. Sparkle, another good example. A lot of applications these days, you're using Sparkle to kind of annotate things on that operational side, right? You find something, you want to use Sparkle to pull RDF information, to mark that up, give a lot more context to it. But the sort of Sparkle I'm talking about here is more you're doing very graph-oriented operations, right? You're trying to answer complex questions, and so it's going out and following edges, and lots of information is coming back to your eNode, and that's going to consume memory. And you don't want that memory to compete with, say, your production side. Consistency checking is another example. You'll often have information represented in more than one way in your database. So you could have a lot of raw information, you could have some aggregate information. It's not a bad idea periodically to kind of validate that. Does this stuff still add up to that, to make sure that your software is running well, your processes are running well. And then the last is investigative and ad hoc queries, right? So sometimes you don't know up front what it is you want to do. Let's say something particularly good or particularly bad happened in your business, and you want to understand why. In the first case, you want to be able to make more things happen like that. In the other case, you want to hopefully prevent it from happening again, right? But that can involve getting a lot of data. It may be doing long-term trend analysis, averages, looking for outliers, trying to figure out what's different about something. And those queries that you do, they're not like what you have in your production system, because you've had a lot of time to think about those and make sure they're exactly what you want and they're efficient and you've got the indexes for them. With this kind of stuff, you're focused on this problem, and you may not have the right indexes. You may not be doing it in the most efficient way. It didn't occur to you at this moment. And so these things can even accidentally run longer, take a lot more CPU, a lot more disk memory than you expected, because they're just not vetted as well. So what can we do? The first thing you can do is you can separate out, and you can create a separate set of analytics eNodes. So you've got different code there. This is where you're going to run all these sort of analytics jobs that aren't the little fast-paced small transactions of your operational system. And so this lets you then choose different hardware. So if this is real heavy lifting analytic kind of stuff, you may scale this hardware up, give it more memory, more CPU. If it's a reporting tier, you might opt to say, what? Performance isn't as big of a deal. Let's scale it down. Let's save a little money. If we're in AWS, we'll have a smaller instance size. But you can choose it to match what you're doing. And then once you've done that, you're going to have different configuration on it. So you're going to increase cache sizes or decrease cache sizes to match. If you think about the jobs in the production side, they're these small, don't consume a lot of resource jobs, very fast running. So you want lots of threads, right? Your app servers, your task servers, lots of threads, because that stuff's all running in parallel. You get to these jobs for analytics, and they run long, they consume a lot of memory, they chew up CPU. So you're probably going to dial back on the number of threads, because you don't want to have so many of them running in parallel. You want to let them run through to completion so that they can consume the resources of this machine you have. So this works great. It gets CPU and memory load off of your production side, but there's still a chance you can cause sort of performance degradation over there, and that's some of the things I talked about where you're laying hands on many, many documents to do your processing on them. That puts I/O load over there, and so that can get in the way of your production side. So you should monitor. You should keep an eye of, what's the response times of these endpoints you're hitting, and if you observe there's a problem, you can go a step further. So you can pull your analytics out into an entirely separate cluster. Now remember, Kaio talked about scaling up for many readers, where you had lots of clusters that things were reading on. It's kind of a similar thing, except in this case, it's running different code, right? It's not a bunch of things running all the same code. And you can seed it in the same way. You've got, you can start with a disk snapshot, or if you have a recent backup, you can restore into that system to get it close to what the data is, and then database replication will synchronize things up. And now at this point, you're pretty well firewalled from the production side to do whatever you're going to do over there. if you are reading tons and tons of documents over time, you're not putting I/O load on your production side of your house. You still can potentially impact it though. Like let's say you scale down to a less capable system because you're not so concerned about reporting runtime, and you're keeping replication, trying to keep it in sync, and you've got this fast, highly capable production system who's trying to throw transaction journals over and get them replayed. He's going to fall behind, and eventually that's going to lag your production system while it waits for it to catch up. Right? So if you get into that situation of high transaction rate and a less capable replica, that can be a problem. And so all you do is stop replication. We have a flag, you turn it off, and now these are completely isolated systems with a consistent copy on your analytics cluster. Run it to your heart's content, beat it up, you're not going to affect the performance. And then later, once that's done, you make a decision. Probably typically depending on how often you do this. So if this is day-end processing, you'll probably reconnect it to replication and sync it back up for your next day's run. But if this is something you do monthly, quarterly, year-end, something like that, you'll probably just throw this analytics cluster away and make another one in the same way when you need it again. Depends on what you're doing. Okay, so that was that use case. So another one I'll talk about with multi-master and distributed applications. So global organizations. How many people here are spread across the world with your companies? Data on multiple continents. Pretty common problem. Naturally, you want fast access to all the information in your company. You want ACID transactions, right? You want it all. But it's global. There's no free lunch. If you are trying to do transactions, right, you think about what you have to do. Oh, you referenced a document that's on the far side of the world. Let me just, go 300 milliseconds over there to take a lock, 300 milliseconds back to know you've got a lock on it. Your transaction rate is not going to be not going to be high. So what can we do? Well, you start thinking about your data. You don't usually need ACID transactions across the whole world, right? Typically, there's some geographical area that you work under, and that's good enough for the ACID, right? So let's say we divide it up into North America, Europe, Asia Pacific. Each of those sites, they want ACID transaction locally, and they're probably willing to live a little behind on information coming in from the other sites, right? If I'm in America, I'm okay, my Japanese information is coming in 15, 20 seconds behind. So there's a couple technologies we have to help with this. The first one is database replication. This one, the idea is originally done for disaster recovery, and you have a master database in one location, you have a replica database in another. We're replicating via the transaction logs, forest to forest. And so you have your ACID transactions in your master, the replicas receiving those journal logs, they're replaying them, and so you have ACID consistent views there as well, just lagged a little bit in time. And so this is how you spread information around the world. So now each site has a master and a couple of replica databases. And when you want a global view of your world, you just, that super database across the top of it, there's your global view. You have access to everything. And then with this, there's a couple sort of operational things that come up, like, okay, what if you want to change where somebody's homed, right? And you have a couple choices. You can, if it's a small set of documents, you can just, it's a delete from one location, insert into the other, do it with distributed transactions, XA, and that's an ACID thing. The other thing you can do is you can just take a whole database and promote one of the replicas to be the new master if you're doing the whole set of them, right? And so when you start thinking down that road, it starts maybe becoming more interesting to say, well, it's not just one master database at each location. You might have a handful of them because you want to be able to move chunks of data to other locations at different points in time. We've talked to some customers who sort of want to do a follow the sun of their data. Whichever part of the world is currently live, they want them to have the master copies. So that's database replication. The other thing we built is flexible replication, which was done for information distribution. So what you do here is you can have clusters spread all around the world. They're connected, communicating over HTTP. And at any given site, you're going to do your transaction, right? It's ACID transaction, normal stuff. And any changed documents, we mark them. They get some metadata saying they're changed. And then that metadata is used to push those new versions of documents to all the neighboring systems. And transitively, it'll get its way around the world. And all that's over HTTP, HTTPS. Now, important thing to note, though, is we do that document at a time. So, you have that ACID transaction, 10 documents get updated in your location. Those are going to show up as 10 separate transactions when those documents get replicated, because we're doing it a document at a time. Or if you update the document quickly 10 times in succession, the only thing we guarantee is the final version will get there eventually. Those intermediate versions, it may never see it on the neighboring systems. Okay, so you've got that. Now, if you look at, you've got all these edge systems, you've got notebook computers. That's another way we extended this, because for the military applications we're doing with this, they want their big databases in their bases, but they have special forces going out into the field on missions. And so those guys have their notebooks, and they put queries into the system that say, okay, what is interesting for my mission? What's the information I need? So it's, stuff about the organization they report into, it's the geographical area they're going to be operating in. They'll do queries on that. They'll do queries on, individuals, political entities, whatever they need to do, maybe on weapons that are being used. So with all those queries get registered, and then they receive just the documents that match those queries that they also have permission to see, because we impose our permission model here. And so they take them, they go out into the field, they'll, many cases they're literally sitting in a cave on the top of a mountain with binoculars watching people, and they'll take pictures, they will gather data, write reports, whatever it is, and then they can send it back up either through satellite links or radio links, or that can be sort of slow communication, but it'll get there. Or when they come back to base and reconnect, it'll just automatically push all that information up, and they'll get all new information back down. At that point, other people can collaborate. Analysts can view the information they pulled in, they can write additional reports, and those now are suddenly matching their queries and coming back down to the systems. So pretty good, cool technology. One more sort of interesting feature, which is we have filtering on this. So whenever a document is replicated either outbound or inbound, you can have code lay hands on it. So on the outbound, it's typically, what you'd think of as, well, you're going to strip some information out of the document. If you don't want to share everything, you only want to share bits and pieces of it, you can do it that way. For inbound, that's sort of more anticipated for you receive a new document and you've actually changed a version on your local system, and you use it to detect that change and set this inbound document aside, so you can resolve the conflict. Or if you can programmatically resolve it, you could do it right there. Okay, so yeah, we did this for military applications, and obviously I think most of you aren't in the military, but we think it's good also for things like, say, disaster response, right? You think people going out to aid stations, taking notebook computers, collecting information from people about, their state of health, who they're looking for, family members, where they lived. You go back to the central base, that all gets shared, and you can connect people up who showed up at some other aid station with the rest of their family. Or if you think of, oil, gas, mineral exploration, there's the same thing where there's, some set of reference material you want to take out in the field that you're going to replicate down, and then you're going to be taking measurements and, collecting data that you do in the field. You're putting all that into your notebook computer, and then you go back and it goes back up, and you can apply, once it's back up in the system, you can apply much more computational effort to it with bigger systems. Okay, last case talk about is archival. So, again, you're thinking about your data, and typically by time it has different value to you, right? So there's some set of your data, I'm going to just define it for now as the last year. That's what you need to run that operational side of your house. And people are coming into the web services, whatever. They need access to information. That's what they're hitting. And so, as Kyle talked about earlier, you want that on fast disk. And then there's other content, such as for reporting, and I'm going to call this maybe years 2 through 5. Right? So this is stuff you don't need every day. You can separate it out. It's slower, it's reporting, so put it on cheaper, slower hardware, save some money, because you're not concerned about sub-second response time for generating infrequent reports. And there's a whole other set of data that you're holding on to because you don't want to or you can't get rid of it yet, right? Legal reasons, you got to keep it for 7 years. Regulatory reasons. Sometimes it's, you're keeping it around and some legal case starts up and suddenly it's, oh yeah, we have to keep this around until the case resolves. So again, we can come in with tiered storage on this. Now, Kyle was talking about tiered storage with very fast systems for your ingest and updates and moving to slower systems. But those are all still sort of part of the operational side. So all of that, consider that inside the operational side here. But you can continue with the technology by separating out, that years 2 through 5 that I talked about to separate reporting nodes in your cluster. You can move them off to, really slow disk, NAS, HDFS, S3, right? Something that's cheap and slow because you're not too concerned about your reporting. And the other thing here is with elasticity, these nodes can come online as needed, right? You can grow and shrink your cluster if you only need them at the end of the month. Only have them at the end of the month. Mount the forests, do your reports, and shut them down again. And then your archival stuff, right? The things you may never look at, but you need to hold on to it. You don't need to have those archival hosts even spun up. You're just pushing the data off again to the slower storage. And if for some reason you get audited or there's a legal case or something like that, you suddenly discover I need access to the data, it's very simple. Just spin up a few nodes, attach the forest to them, now you've got them. You would use here a super database across these 3 databases. And the reason I'm suggesting that is, we're talking about performance of databases, and it's keeping the reporting and the archival that you're going to respond very slowly to queries, keeping those out of your operational database is just a good way to firewall it. So I think those are all of mine. I think Kyle's going to come in for a little more.
So I talked a little bit about the roadmap for tiered storage, but we are also working on the archival aspect. And Wayne talked about retaining documents. So you have to keep documents around for 7 years. There are legal requirements. And when we say keep around, it really means it has to be there. So we are doing 2 things to ensure that documents are there. The first, we are integrating, we have APIs that will help you save those documents to warm storage. Warm by definition will prevent you from deleting. But you cannot run a database on top of warm. You need to keep writing and adding things. What we'll add to our ByTemporal is the ability to prevent 3 operations. We'll prevent you from updating. Let's say at the end of the day, the trade closes. You want that trade, you need actually that trade to be around for the next 7 years. So you cannot update. That was already updated. You had a window of 24 hours. So you can prevent for the next 7 years that ByTemporal document be updated. Maybe there's another scenario. Files from an employee. You still want to be able to update because the life of the employee may change. You may add new I-9s about that employee, update information, but you still need to have that information around. If you do a query about employees that you have in your company, it better show up. So we also allow you to prevent a deletion. A deletion in ByTemporal is actually setting a system end time. So it disappears from queries, but it's still on the system. So we can actually prevent you from removing your document from queries. And finally is the wiping. It's really getting rid of the entire document, the set of documents. So by providing these 3 operations, we cover all use cases that we have there in terms of compliance to legislation. And this is enforced at the database level. So only if you do not set the with a bypass, not even an admin could override those. So if you set the bitemporal collection without an override, it's prevented. There is only one thing that can happen: somebody destroys the database, and therefore you have your warm storage. So when you combine these things, it will help you comply to all regulation like FIPS, PHI in healthcare, and ensure that documents are around. So this is not available yet in early access, but it will be available in early access 3. We're still working on this, but very important story across multiple industries: financials, healthcare, and even, as I exemplified, employee records. Those that live in the US and have foreign employees know that you have to keep copies of green cards and so on. Those things have to be around. There is a mandate that will help you achieve that. Wrap up here. So I talked about a few things about separating E nodes and D nodes. And I asked at the beginning, who's already managing MarkLogic? This decision about separating nodes has a consequence. When you separate nodes and you allocate memory for an E node, that memory cannot be used for ingestion. So it's better that you take that decision after observing what is really happening. Do I really have a read-intensive problem, or do I really have a write-intensive problem? So observe before you decide. And typically this decision works better when you have a larger cluster. Okay? There's also more management effort. Once you separate nodes, you have to start thinking about, oh, this is my E node group, D node group. So there's a little bit more effort. But many customers took that route. But I do not recommend you taking that route before you observe. Observe first. Fast Data Directory, I think is very effective, but it still involves buying SSD, which is probably 3 times more expensive than hard drives at this point. But I would say very effective, but there's some cost behind. Tiered storage, we talked about the current version of tiered storage. It does require some changes to the application. You ingested the sub-database. So MarkLogic 8, yes, that still applies. We are solving that in MarkLogic 9. So that will be much simpler in MarkLogic 9. In multi-master, Wayne talked about conflicts. There is no way you will implement a solution that users can detach and update documents and that will not generate conflicts. You will have to think about how to handle conflicts. We do have the filtering that may provide a programmatic way of handling that, but typically there will be conflicts that cannot be handled in human intervention to solve which version stays around. We do have the technology, but typically it involves conflict resolution. We're talking about the many different ways to scale. So very flexible architecture, but you can still go with the simple way, just adding nodes. It works really well. It's tested and true, has been around for the program many years. But before deciding all about these alternatives, remember the questions that I had at the beginning. What I'm trying to solve, it's a query problem, an update problem, ingestion, analytics. Is something outside the normal operations? Think about the problem, observe first. Think about, is all data equally important? Maybe you're having a performance problem because you're handling all data in the same way. If you tier that data, you can accelerate queries for new data. Location of users may affect how you distribute data. Or as I exemplified, if some users are okay having lagged information, Wayne also described about this, try that. It will help you a lot. Most alternatives will add to the management effort. For alternatives such as transient clusters, you have to have an automation tool. You have to have something like Chef or other tools to help you automate that. Most solutions that we describe is set once and forget, but some do require management tools. Think about that. And finally, there may be some cost when you add SSDs and so on. But overall, MarkLogic provides a simple solution to scale and many alternatives. With that, I would like to point to additional resources. I told about early access is already available for tiered storage. We do have a paper about understanding system resources, and there will be a session this afternoon about developer tuning with Aaron Miller and James Kliplinger, or Klip, that they will talk in details about E nodes and D nodes and so on. We have an updated version of the Inside MarkLogic. So if you have already read that document, revisit. We added more information. And the paper that I said, we are working with Intel testing new storage technology that shows some great performance numbers. Okay, so now Wayne and I are open to questions. Yes?
So, is there any option for metering? Like, for example, for these type of requests or these clients, I want to give more time or more request comparatively with other clients. Is it possible to do that thing? Like in web application,
Just repeat the
make
question.
sure that
Yeah.
metering, right? So if I get so many requests from a client A, then he gets more priority than client B. Is it possible to do?
Yeah, so the question is if you are able to prioritize workload based on clients.
Not directly. If I were to think about how you could come to that, that endpoint, I would say, well, if you have multiple app servers configured such that one gives better response than the other, right? One has maybe more or fewer threads than the other. If you decide when somebody's hitting the less capable one, perhaps that you want to send him to the other one, you could perhaps send him something in the response or a redirect that would send over to the other one, right? So you could kick him over there. That's about the only way I can
I would
think of
say
that you
it
could
would
do
be a
that.
combination of your load balancer, understanding the behavior of the customers, and pointing to different app servers. From MarkLogic side, it will be just an app server.
Another end, but is there any feature or a planning for a future database itself? Because you do have app services already inside the e-nodes, right? Basically.
Yeah.
Right. Yeah, I don't. There's nothing in the plans for
No.
that.
Like quality of service, no, we don't have that.
Is there a way to monitor the lag for the replication?
Yes.
Yes. We have an API, a REST API that it can use. We also have our graphical user interface that will also help you check that. So 2 ways of looking
Yeah.
into that.
And XQuery and JSON or
Yeah.
JavaScript as well. It's on the for status.
Part two of that, you mentioned that if the target falls behind, then it could start to slow down the master.
Right.
Is there any ways to control that, to change the asynchronous value to?
So we do have a lag, which defaults to 15 seconds. Experience says, though, that increasing it doesn't give you what you want. What tends to happen if you monitor how things go, I use an analogy. You've got two walkers with a string between them, right? One's slow, one's fast. And you would think that once that string extends, they would just go at the speed of the slowest one. And that's not what happens in reality. When it hits its limit, the faster walker stops until the slower walker catches up, just because, time is moving on, and those the lag is always there.
So there's no way to make it less synchronous?
Well, the one thing we have people doing when it's a big concern is they're monitoring lag on their master, and if it gets too high, they disable replication.
And can you restart it?
Yeah, when you re-enable it again, it will automatically resync. And if your journals are still there, it's just a journal replay. Otherwise, it goes through the bulk replication and journal replay.
How does licensing work with using the DR as a read-only copy?
Yeah, in that, what? No, it has not changed. So in that scenario, since you are using those clusters, it's licensed. Yeah. So, but it's a way to scale. Consider that if you're scaling, you would have to have more licenses anyway. We're just leveraging and allowing it to separate and segment. That's the concept. Yes.
Can we spun up like an e-node in the cloud to handle certain like temporary analytic type of ad hoc query type of thing, and after that we just shut it down.
Mm-hmm.
But so the question is if you can spawn e-nodes in the cloud.
Mm-hmm.
But my question is the cluster on-prem and you're just creating it in the cloud. If the e-node is too far from the d-nodes, there's too much lag there, you will probably not achieve good performance. Going back to my example that I said about mastering in multiple replicas, that master is actually on-prem, and only those other clusters were on Amazon. So that means that if you want to create something in the cloud, you have to create a cluster that will have some data there. So you need to start replication. So e-nodes and d-nodes are close to each other, meaning that there's not too much latency. Because if you go across too much latency, you're not getting any benefit.
Can we say like a preload certain collections into the memory, like a expanded tree cache, if we know the memory can hold that amount of data?
We talk a little bit about warm-up queries. If you do a warm-up query, that will load those documents to the cache. That's typically what we talk about, and that will be covered in the session later today, specific about what developers can do to speed up that as well.
I have two questions. Maybe the first one was asked, so I'll ask the second question first. When you split the e-node and d-node, how do you size the e-node? You know, the old rule of thumb of 2 cores per forest. Now on e-node, they don't have that anymore. How do you size the e-node?
Yeah, so that's why I said you should be monitoring the utilization of your caches to figure out how much memory you should allocate to your e-nodes in terms of expanded tree cache. That's the first decision that you need to find out. Then if you go to monitoring history, you can actually figure out how much CPU your app servers are consuming. You can disable a few things and just, that will also help you figure out of my current resources, how much CPUs are being used by app servers. That will give you a good indication about what you need to do when you segment. So that's why I said it's better to observe. It's really hard to, without information, figuring out what to do.
All right. So the other question is, I think Wayne has a slide where it says the operational e-nodes and analytical e-nodes. If they are in the same cluster, and they are not identical, because operational may have some other reporting versus analytics, maybe bigger, different code base. How do you deploy different code base to the same cluster nodes?
So you're going to put them in a separate group, right? And the group defines all the app servers that are on them, and the app servers reference the code. So you know, if it's in a modules database, it may be served up from those D nodes, but you're running that separate code on the other group, right? And also for messing around with things like cache sizes and numbers of threads and timeouts and stuff, that's all group level as well.
So the entire analytics group of nodes, it will be a group. That's it.
Yeah.
And then you set up separate cache values.
If it makes sense, you can have multiple of those analytics groups tied to specific uses that you have.
Can you configure the cache bases, like compressed cache, like source and source?
The question was about configuring the caches. All caches are configurable at the group level. And you will separate, for instance, the analytics nodes as a separate group, and then you set, for instance, more expanded tree cache because you're serving more Sparkle, for instance. You may want to have more cache as well for Sparkle, triples, and so on. Yeah, it's a per group. It's not a per node.
I actually have 2 questions.
Yeah.
One, when you are adding the nodes, right? The newer nodes, would you recommend those newer nodes be on the same configuration as like older nodes from the memory CPU perspective, or there doesn't need to be?
Okay, so I'll tell you what would happen if you add slower nodes. That node will be the bottleneck. Okay, there's no question. So never add nodes that are slower without segmenting to a new group, without completely separating that into a new app server. So if you're adding to the same group and the same app server, same database, it better be as fast as the other nodes. Having faster nodes, unlikely to provide any benefit. But what customers do, they will add faster nodes, and then later they can segment the cluster to have these faster nodes be a one tier and the older nodes be another tier. So you can grow in that way, but never add slower nodes. It will always bottleneck everything.
And second question, follow up to the DR related one someone asked before. So to run the queries on DR, do we need a separate license, or?
Yeah, you will have to license the DR cluster. Yeah, yeah. But again, my point is you already need to scale. What I'm saying is you can scale on your DR solution and leverage the isolation as well. Yes?
So separating different versions of code. So for development phase and maybe some testing and deploying, and maybe it's not running well, then I have to do a fallback. It's done in groups or in web servers, or how do you?
You could do either, right? Like if you create a separate app server, it can run your new code, right? You just have to figure out how people are going to call it.
Okay.
I was talking to somebody, was it yesterday, who's saying they roll forward like just one of their machines to the new code, but leave it in the load balancer and kind of just monitor how it's doing and is it behaving like the others, right? So you can have a group with same app server port number, and you can maybe move one host over there, running the new code, and
so
seems to be going well. Okay, let's move another host over, right? And kind of until you're all running the new code.
So all the continuous delivery techniques like triggering also are working perfectly in this environment, right? Okay, thanks.
Yeah.
And to add to that scenario, as Joe Pasqua mentioned this morning, you can also add a roll and upgrade, upgrading MarkLogic as well, testing new code and see how it's going before you commit to the entire cluster.
Another replication question. Sorry. What indicates to the primary that a particular journal entry has been processed by the replica?
It acknowledges back.
It means it's received it, not that it's applied it or written anything.
Current implementation, it has written it to the journal and replayed it.
And replayed it
and
as
replayed
well.
It, yes.
So everything is hardened to the disk before it's done. So
Yep.
if there's some problem with the replica, that would cause the primary to stop as well.
Yeah. So the obvious thing, you're aiming at HA.
Right. But you may not, in some circumstances, you may not want them to be so closely in sync. I mean, if it crashes for some reason, maybe you want to continue with that.
So to be clear, are you talking database replication or local replication?
DR.
DR?
Rep.
Database replication.
Database. Okay. So what happens is we do have timeouts on that.
Okay.
Right. And if we're trying to get stuff out there, well, we're dropping it into the queue to go.
Right.
It's going at its rate. And if that stops progressing and we get an error or it times out or something like that, sort of that state of sending the journal frames just all falls down and drops out of the way, and we no longer try and send something to there until we've reestablished communication and gotten it back up, resynchronized again.
That's for DR. For local, as he started describing, the purpose is you have to ensure that you are not losing ever information.
Right,
That
right.
is the different behavior, right?
But in the local disk, even if your replica goes down, the master soldier's on, right? But there's a timeout, right? Before he decides, okay, he's dead, move on. Because when you're designing for HA, oh gee, my backup went down. I don't want my primary to go down.
Right. No. Yeah. I'm thinking more of DR, not HA. And is that configurable? The timeout time.
Yeah, we have a lot of timeouts for different things. It's tied to one of them. I forget which one offhand.
Okay.
So unfortunately, I think we're out of time.
Over time now. Really appreciate the questions, and we'll be around. Thank you.